With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The question given here is how many of the given statements are correct here. So various statements are given here and we have to check which of these statements given are correct. So let us see first statement given here, that is molar entropy of a substance follows the order. So we have to check the molar entropy of each of the substance. Molar entropy means the entropy possessed by a substance, 1 mole of a substance. So here we can see that the order is given that the molar entropy of the solid is less as compared to the molar entropy of liquid, and it is also less as compared to that of entropy of the gas here. So it is a true statement because here you can see that as we move from solid state to liquid state, the degree of randomness is increasing. The intermolecular distance between the molecules is increased from solid state to liquid state. That is why entropy is also increasing. But if we consider the second case, that is when liquid state is converting into the gaseous state, there would be more increase in the randomness. So you can say here that as the degree of randomness here increases, degree of randomness as increases, that is why the entropy is also increasing from solid state to gaseous state. So you can say that the first statement given here is correct. Now let's see the second statement given here, that is the entropy change of the system for the reaction, that is hydrogen is getting converted into 2 hydrogen atoms. This is positive. So let's check out this reaction here. In this reaction, what is happening? 1 molecule of hydrogen is getting converted into 2 atoms of hydrogen, isn't it? There is a dissociation of a molecule of hydrogen, then it is giving us 2 atoms. Now if you want to calculate the delta Ng for the reaction, it would be coming positive, that is 2 minus 1 would be giving us value 1. Okay, so there is increase in the number of moles in the reaction. Okay, you know how to calculate the delta Ng value, that is the number of moles of product minus number of moles of reactant. So it is positive here, so you can say that as the number of moles are increasing, the degree of randomness would also increase in this direction only, or you can say the change in entropy will increase here. So you can say here the statement second is correct because the entropy change is positive in this case. So yeah, it is a true statement. Now let's check out the third statement which is given here, that is the molar entropy of a non-crystalline solid will be 0 at absolute 0. For this, let us consider the third law of thermodynamics into consideration. What is the third law of thermodynamics? Third law states that for the pure crystals, what happens? For crystalline substances, you can assume the entropy to be 0 at absolute 0. At absolute 0. Okay, so you can say here that the statement third is incorrect here because it is telling us about the non-crystalline solid, whereas the third law states that only crystalline solid will have 0 at absolute 0. Okay, now let's check out for the statement fourth here, that is saying that if the path of an irreversible process is reversed, then both the system and the surrounding shall be restored to their original state. But here we are talking about the irreversible process only. If the process is irreversible, then it cannot be reversed back. Okay, and we cannot attain the original states here. That is why this process is termed as irreversible only. No? So we can say this statement is absolutely wrong here. Now let's check out the fifth statement given here, that is the refractive index and molarity are intensive property. So yeah, these are intensive property. This statement is correct here, true here. Why? Because you know what is the intensive property? Intensive property which doesn't depend upon the mass of the substance taken. If you would have taken this much large you are taking into consideration this much large area of a substance and you are picking up simultaneously this much small area of the substance, then would the refractive index of the substance will get changed? No, the answer is no. The refractive index would be same for both the pieces. Okay, and similarly, let's talk about the molarity. What is the molarity? Molarity can be explained like this. Molarity is the number of moles of the substance dissolved in volume. Okay, that is measured in liter per liter of the solution, isn't it? So we can say the number of moles is an extensive property and simultaneously the volume is also an extensive property, and it is a rule that if we want to derive a formula in which is the equal to ratio of two extensive property, then we can say here the molarity, that is the resultant property, would be intensive in nature. You can look into this in another way also. If you are taking a vessel full of a liquid having particular molarity, let us assume it to be 1 molar, then if you pick out a spoon of this liquid, or you can take out a small jar, small flask of this liquid, then also the molarity would remain 1 molar only. Okay, so molarity is not changing by changing the mass of the substance. So you can say it is an intensive property. So you can say here that first, second, and then fifth statement is correct here and 2 are wrong. So you can say option 3 is the correct answer.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.